All right, this is the second video with some different examples. Um, this is where it gets a little bit trickier. We have to use more of what some of the skills we've used in the past, some of the algebra skills that we may have forgotten temporarily, but it'll come back quick. So I'm going to do number 5. It's down here, and I'm going to move the screen in a second, but I want to note that we're looking at the g function because in number 5 the function's name is g. So it tells us immediately which of these we'd be using, not f or h in this case. And I'm also going to write it down, x squared minus 3. I'm going to write it down here. So just to give us some room, it was x squared minus 3. Okay. So this is g of x is equal to x squared minus 3. That's the function we'll be using. And when we plug it in, everything's the same. X, and now instead of x is m minus 4. And then that x was squared, so this has to be squared. And we just have a minus 3. And the reason why this is in a separate video is because this gets a little ugly. A lot of people, when first doing this again after a while, are going to say that you can evaluate this piece as m squared minus 16. You know, and it kind of makes sense. You know, we had a little trick earlier where we can give this exponent to both of the terms, but that's not accurate. Because of this minus sign, it complicates things. So we have n minus 4 squared. You can kind of take that off to the side and mess with it a little bit. Just write it out to see what it looks like. That's helpful. So we're going to go, it's squared, so there's 2 of them, m minus 4, m minus 4. And then this should bring us back to, oh yeah, that's right. If we have like a binomial, meaning there's 2 terms in parentheses, multiplied by a binomial, we have to do, and this is multiplication, so we actually have to distribute. It really, there's a lot of distribution that needs to happen. Basically, both of this m needs to get distributed to both this m and this negative 4. And this first negative 4 needs to get distributed to both this m and this negative 4. We have a better acronym for it called FOIL, but we shouldn't necessarily rely on using FOIL. You know, if there's 3 terms in this second parentheses, FOIL doesn't really follow as well. It's just fancy distribution. Just make sure, however you do it, that each term in the front gets multiplied to each term in the back one time. So, but people remember FOIL, so we'll start that way. First terms get multiplied together. That's m squared, because m times m is m squared. Then your outside terms you can multiply. That would be m and negative 4, or negative 4m. And then your inside terms is negative 4 and m is also a negative 4m. And then our last terms. Negative 4 and negative 4 multiplied is a positive 16. And we can't forget that the last part is these 2 terms in the middle are like terms. So this is m squared minus 8m plus 16. That's what this whole chunk turned into, because we took it over here, messed with it, and figured out what it was. And it simplifies to be this trinomial. So bringing it back, we get m squared minus 8m plus 16. And we still have the minus 3 over there, so we can't forget about that either. We haven't been able to do anything with it, but now we see that we do have some like terms still. M squared's alone, there's no other m squareds. M, or negative 8m, is alone, there are no other terms with just an m. But 16 and 3 are like terms because they both don't have an m. So we can simplify just that part, and you get 13. So g of m minus 4 is m squared minus 8m plus